MISC proposes RoboFix, an AI-powered predictive maintenance and wear optimization software for industrial robots. So, RoboFix is a full-stack AI system that takes any industrial robot sensor data, detects which joints are degrading, and predicts how quickly they'll wear out, and recommends best replacement materials. And this is all visualized with our intuitive interactive 3D robot model. The problem is industrial robots operate under constant mechanical stress. Joint wear leads to unplanned downtime costing manufacturers thousands per hour. Current approaches rely on scheduled maintenance, replacing parts on a calendar and not actually based on their condition. So the question is, can we predict which joint will fail next and what material would make it last longer? This is aligned with sustainability for longer turnover rates in machinery. So how it works, the pipeline. Firstly, there's the ingestion. Any CSV schema is put into the system and the sensor data, whether that's accelerometers, gyroscopes, vibration, torque, temperature, all of it is taken into account. And then feature engineering takes care of processing all of the different types of data imported from the data set. And then there's the anomaly detection system, which is actually based on machine learning. And then there's the wear estimation, which is actually a physics-based model inspired by Archer's wear law. And then there's a material recommendation system, which tells you which material would be better to reduce the wear. And then there's the 3D visualization that you could actually use to click on the joints and see which joint has worn out by how much. And here are the technologies, the tech stack, and the key differentiators are it's dataset agnostic. So the majority of datasets should work on some level with the software right out of the box. And then there's a user configurable pipeline, so you can actually have deselection and downsampling, etc. And it's physics grounded, so it's very much rooted in the real world, and it's cost aware. And there's all sorts of ML diagnostics as well, and an export feature that gives you all of your metrics in a localized PDF export format. So why this matters? Because it's aligned with SDG point number 9, industry innovation and infrastructure, and also responsible consumption and production. So now we'll be moving towards the next steps. You can see them here, and then transitively from there to the demo. So the demo is over here. Now we actually can import a data set over here. So let's say I want to use this data set over here. So it's going to run it in, and it's going to take approximately a minute, this data set in particular. So I'll pause it here. All right, so this is the current progress. It's at 56 seconds with the anomaly detection. So there are multiple ML algorithms and systems running in the background. There should be 4 models that can be used as detailed earlier. It may take longer at some times because of the system load. There's a lot of applications concurrently running at the time. So I will pause it further. Okay, so now it's generating the ML diagnostics report, and we should see the results. Okay, so over here, we actually have the 3D joint system. And if you see here, you click on it, it gets you the joint health. And over here is the joint wear analysis according to the joint part. And over here, it's actually the material recommendations. And the innovative part of it is that you can actually rank it by practicality. So it's a ratio between the density and other related factors and actually the hardness. So you have a good balance between weight and the amount of wear reduction that you will have. And this is the sensor timeline data and the wear forecast. You can actually get a material impact, so you can kind of see the comparison here and also scale it differently to get a better idea of the trend. And then you can also hit export PDF report, and you can see the report here in this PDF file format. And if you go back here, there's actually a joint repositioning system alongside these ML diagnostics. So if I run compare all models, it'll actually run a whole bunch of models here. Okay, so as you can see here, it has actually generated a comparison, and autoencoder is the best. And over here, you can actually modify the joint layout manually, or use auto arrange arc if you upload like a robot side profile over here. And that's about it for the functionality. Thank you.